One document contained the full schematic for an unreleased Apple server, codenamed Matterhorn, dual 32-core CPUs, 24 sticks of RAM, Nvidia T4 GPU. A blueprint for tomorrow. In May 2026, Foxconn was hit by a cyber attack linked to the Nitrogen ransomware group. Nitrogen claimed to have stolen that document, and millions more. 8 terabytes, they said. The alleged haul from Foxconn's North American servers. The attack crippled parts of the manufacturing giant, forcing a revert to manual processes. But the real danger was the server documentation and engineering data at risk, a supply chain breach that created downstream pressure for partners like Apple and Nvidia. Nitrogen claimed to hold the keys to the kingdom. Now Foxconn's security team faced an impossible choice: pay the ransom, or watch the future of technology get auctioned to the highest bidder. Every iPhone you've ever swiped, every GPU training tomorrow's AI. The odds are, it passed through a Foxconn production line. The Taiwanese manufacturing giant doesn't just assemble electronics, it holds them. Every schematic, every instruction set, every unreleased design. For clients like Apple, Nvidia, and Google, Foxconn is where tomorrow's products exist as raw data, before they become hardware. Proprietary manufacturing instructions, component schematics, confidential project files, the kind of information that never leaves a partner's secure network until it has to. And here's the paradox, at the heart of modern tech manufacturing. To build at scale, you must share everything. The full blueprint. Not a summary, not a reference sheet. The complete, build-ready engineering package. That means Foxconn's servers hold the proprietary data of hundreds of competing firms in one place. A necessary risk for the promise of production at global scale. The Apple Matterhorn project proves the point. The stolen files weren't conceptual sketches. They were complete hardware schematics in Siemens NX format. Dual 32-core Intel Ice Lake CPUs, 24 sticks of 128GB RAM, Nvidia T4 GPUs, multiple 8TB NVMe drives per chassis. The full manufacturing blueprint for a server that hadn't been announced yet. Entrusting a partner with this level of detail isn't unusual in high-volume manufacturing. But it does something dangerous. It creates a single, catastrophic point of failure. By centralizing the crown jewels of the world's largest tech companies, Foxconn had inadvertently built the most valuable target on the planet. For years, this arrangement functioned. The trust held. The shipments moved. But trust, in cybersecurity, is just another word for unexamined risk. And that fragile assumption was about to come apart through one critical breach, with consequences that would cascade across the entire industry. On March 12th, the Nitrogen Group's leak site listing made one thing immediately clear. This was no ordinary ransomware attack. Security analysts zeroed in on a meticulously executed double-extortion campaign. Two levers of pressure. Two ways to bleed Foxconn dry. The attackers weren't just holding operational systems hostage. They were preparing to auction their partners' most valuable secrets. The initial encryption was the loud part, the part designed to make everyone look left, while the real heist had already happened to the right. Unlike indiscriminate attacks that cripple entire networks for a quick payout, this was surgical. The threat actor leveraged a double-extortion model, encrypting systems to disrupt operations while stealing sensitive data as extortion leverage. Forensic analysis of the sample files leaked by the Nitrogen ransomware group confirmed it. Genuine Apple server schematics created in Siemens NX format. A curated collection of the most sensitive assets from Apple, Nvidia, Intel, Google, as if someone had walked through a vault and taken only the rarest gems, leaving the costume jewelry untouched. By stealing the data before Stimes encrypting the network, Nitrogen created a second, more powerful point of leverage. Think of it this way. Even if Foxconn restored every system from backups, even if they rebuilt from scratch, the stolen IP remained a catastrophic, unpatchable vulnerability. You can restore data. You cannot unring a bell. The public confirmation of the breach came on May 13th. Then, on May 20th, industry reporting verified the leaked dataset contained the complete schematics for Apple's Matterhorn server project. The claim was real. The damage was verified. Nitrogen had successfully exfiltrated the blueprints for a core piece of future infrastructure. Nitrogen claimed 8 terabytes, over 11 million files. A haul so large it required its own logistics, not just a hack, but an extraction operation. But while the breach's scope was publicly unfolding, the real impact was already rippling silently through factory floors and corporate war rooms, and the companies on the receiving end were only just beginning to understand what had been taken and what it would cost them. Script: NTHE cyber attack struck Foxconn's Mount Pleasant campus without warning. Critical systems didn't just slow, they stopped. Networks went dark. Quality databases locked. Production lines built for surgical precision, frozen mid-step. For a company defined by automation, the consequence was immediate and humiliating. Paper instructions, manual checklists, runners carrying hand-written tickets across factory floors. In May, Nitrogen had claimed the breach. The world's most advanced contract manufacturer reduced to clipboard logistics. And in May 2026, Nitrogen had claimed the breach. Within days, the encryption cascaded through facilities across the continent. But while Foxconn scrambled to contain the internal damage, a far more consequential alarm was already sounding in Cupertino, Santa Clara, and Mountain View. Niche client Apple, Nvidia, Google now face the same impossible question: which of our confidential files are now in criminal hands? Niche client Apple, Nvidia, Google, Samsung, Seagate now face the same impossible question: which of our confidential files are now in criminal hands? Each client, Apple, Nvidia, Google, Samsung, Seagate, now face the same impossible question: which of our confidential files are now in criminal hands? The perimeter they trusted wasn't theirs, it was Foxconn's, a chain of North American facilities. And it had just been breached. NNA's single supplier security failure had exposed confidential data and infrastructure documents tied to multiple major tech clients. NNA's single supplier security failure had metastasized into a systemic exposure event for the entire technology sector. A single supplier's security failure had metastasized into a systemic exposure event for the entire technology sector. The blind trust woven into global manufacturing had been weaponized, turned from an efficiency advantage into an attack surface. While security teams scrambled to map the damage, the true cost was already crystallizing. It would not be measured in ransom payments or production delays. The schematics, the engineering files, the unreleased project documentation. Once that data leaves the building, there is no unleaking it. The exposure was permanent. And for every company whose files were now in criminal hands, the deepest part of the crisis was only beginning. Closing curly bracket, closing square bracket. The ransom demand was a negotiation. The data leak is a permanent condition. This is the cruel logic of double extortion. The threat of exposure outlives any negotiation. The exfiltrated data ceases to be a bargaining chip. It becomes a weapon poised for disclosure on leak sites. You can recover from a financial loss. The exposure of intellectual property is absolute. A server schematic, once seen, cannot be unseen. The core damage is not a one-time cost. It is the indefinite, irreversible erosion of competitive advantage, a liability with no expiration date. Now those stolen files gain a predatory life of their own, creating new categories of strategic risk. Competitors could potentially use these stolen infrastructure designs to neutralize years of R&D investment. The stolen data presents a theoretical intelligence resource for understanding the engineering architecture of major technology systems. The files, architectural maps, network topology diagrams, and engineering documentation represent operational intelligence that could facilitate future infrastructure-focused cyber attacks. But perhaps the most insidious modern risk. This vast trove of engineering data could theoretically be leveraged to train specialized AI models. A partner's proprietary IP is now raw material to forge an adversary's tools. The leak does not just reveal what was built, it could provide the raw material to replicate server and data center infrastructure designs. This incident transforms from a corporate crisis into a stark example of third-party supply chain risk. The model of consolidated trust, entrusting a single supplier with the secrets of an entire ecosystem, has been proven fragile. There has long been an assumption that supply chain efficiencies of relying on a single manufacturing partner outweigh the security risks. That calculation has been thrown into question. The breach forces every technology firm to ask if proprietary secrets can be protected by a contractual agreement alone. The fallout demonstrates that the cost of such vulnerabilities is no longer theoretical. But if the old system of trust is broken, a new question emerges. How must the entire security architecture be re-engineered for a world where your weakest vendor is your strongest point of failure? The Foxconn breach is more than a cautionary tale. It is a definitive case study for one critical security principle: the vendor blind spot. This is the moment a trusted supplier's security failure is multiplied across every client it serves. One breach at Foxconn, and suddenly Apple, Nvidia, Google, Intel, all compromise simultaneously. A single point of failure becomes a systemic industry crisis. The defensive lesson is architectural, not just procedural. Companies cannot simply patch their way out of a problem they outsourced. Businesses must evolve aggressively from trust and verify to zero trust, especially for shared intellectual property. That means segmenting data flows between partners, treating every connection as potentially hostile, enforcing strict, granular access controls based on verified need, not assumed trust. The handshake and contract era is over. The supplier relationship must become a technically enforced security posture, where data is compartmentalized by default. This demands a radical shift in operational readiness. Incident response playbooks must be rewritten to activate not only when your own perimeter is breached, but when a Tier 1 supplier shows any sign of compromise. A supplier's incident is your incident. That requires pre-scripted containment actions, redundant data access protocols, and immutable, offline backups of critical manufacturing data. Operational continuity depends on it. Waiting for a supplier's official confirmation is waiting too long. The Foxconn breach was not a failure of technology alone. It was a systemic failure of a security model built on an outdated definition of the corporate boundary. Before we conclude, this analysis is educational only and does not provide exploit instructions. With the lines between partner and perimeter now permanently erased, how can any organization be certain that its most trusted vendor is not also its greatest vulnerability?